Good day, virtual pilots. Welcome to this training presentation of the VATSAF PTD. Today we will be exploring the cockpit of the Cessna 172 or the Charlie 172. This is the preferred training aircraft of the PTD for obtaining your P1, P2 and P3 ratings. During the presentation, I'll be moving around the cockpit, zooming in and out as we discuss the various of instruments available and the uses thereof. Sit back, relax and enjoy. The first instrument is the airspeed indicator or the ASI. This instrument measures the speed of the aircraft through the air. It is generally divided into knots and may differ from aircraft type to aircraft type. To assist the pilot, the modern ASI is further color-coded in various of speed ranges, and in some cases it will even have certain speed markings. The white arc. This is the operating speed of this aircraft with flaps being extended. The section of the white arc where the green arc starts, that is the speed indication of this aircraft for stalling with full flaps and gear down under no power. From this range onto the white arc to that range over here is the speed indicated of this aircraft with flaps extended. The green arc is the normal operating speed of this aircraft. At the end of the green arc to the start of the yellow arc is the course and speed range, and this will obviously be your VNO mark, which is your maximum structural cruising speed of this aircraft. The yellow arc is an indication of your course and speed range, and this aircraft should only be operated in the speed range in smooth air. Then we have our red line, or what we call our VNE. This is our never exceed speed, as the manufacturer cannot guarantee this aircraft's structural integrity with speeds beyond the red line. Some ASIs have an adjustable altitude and outside temperature settings, which can be adjusted by the pilot, with a true airspeed scale on the outside of the green arc. This will assist the pilot in reading and matching his true airspeed from the ASI with L calculation, and this is valuable for navigational purposes. Always consult your pilot operating handbook for the exact marking denotation to your specific aircraft. The second instrument of the six primaries is the attitude indicator, or the AI, also known as the artificial horizon, or the AH. This instrument displays the aircraft position relative to the Earth. It will display the aircraft pitch attitude and the bank angles in degrees. So let's take a closer look. Firstly, we have the aircraft indicator. This will indicate the position of your aircraft. Secondly, we'll have the pitch line. This depicts your position in relation to the aircraft pitch, either up or either down. Then we have the bank angle. The bank angle is divided. The first line obviously is your 0 degree line. That means your aircraft is straight. The second small or sub line is 10 degrees, and it can either be left or right. Your second sub line will be 20 degrees, either left or right. Your second fat line is a 30 degree bank angle, and then your third line will depict a 60 degree turn, either left or right. Further, you will have an adjusting knob, and this knob should only be used to adjust your aircraft pitch if the aircraft is stationary and it is on a level surface. Normally we don't adjust these little adjustment knobs. This instrument does not indicate any aircraft performance. and should be used with your airspeed indicator or ASI, also with your vertical speed indicator and your altimeter. The third instrument is your aircraft altimeter or the ALT. This instrument will indicate the aircraft's altitude above mean sea level. In the ALT, you will have two pressure windows to this specific aircraft. On the right, you will have mercury inches, and on the left, you will have the millibar setting. You'll have a strip display setting, and this will only be visible if the aircraft flies below an altitude of 10,000 feet, depending on your pressure setting. Altitude indication is done via these three little arms. They look like a clock, and I will refer to them as the short clock or hour arm. This indicates a decrease or increase in altitude for every 1,000 feet. Then you will have the minute arm, and this will indicate your increase or decrease in altitude for every 100 feet. Lastly is the second arm with a little indicator. For every 10,000 feet of climb, it will move on one position. So that will indicate your altitude in 10,000 of feet. Lastly, we have an adjustment knob. There you can adjust your aircraft pressure according to the current METAR or as been instructed by ATC. The fourth instrument is the turn coordinator or turn indicator. This instrument will indicate the rate of turn and not the bank angle. This is of value to ensure all turns are balanced in relation to the turning forces on the aircraft. The main scale indicates a rate 1 turn, 3 degrees per second. That equals 180 degrees in 1 minute and 360 degrees in 2 minutes. You will see that the plate indicates that if your wings are on these notches here, that you will be doing a 2-minute turn, which means you will turn 360 degrees in 2 minutes. Second part of this instrument is the balance indicator. When you do a turn, always make sure that the ball stays in the middle. If the ball flows to the outside, the aircraft is skidding out of the turn. If the ball flows into the inside, the aircraft is slipping into the turn. Keep the ball in the middle by applying rudder relative to the ball position. So if the ball is to the right, apply right rudder. If the ball is to the left, apply left rudder. We call this method stepping on the ball. The fifth instrument is the direction indicator or DI or the heading indicator HI. This indicates the magnetic heading of the aircraft during active flight and movement. This instrument needs to be aligned with the compass periodically from 10 to 15 minutes, and it's normally simulated in most modern simulators today. Firstly, we will look at the main dial. The main dial is divided into degrees from 0 to 360. It's like a flat compass. We have the heading bug indicator. This is a visual indication tool to ensure maintaining the correct magnetic heading of the aircraft. This instrument is also equipped with a slave knob, and the slave knob is to adjust the DI or directional indicator to your compass. Lastly, we're having the heading knob, and this will adjust the bug to the desired magnetic heading of the aircraft to fly. The sixth instrument is the vertical speed indicator or the VSI, and this will indicate the altitude changes in feet. We'll have the zero line. The zero line indicates that this aircraft is now in level flight and there's no altitude change whether it's up and down. The plate is divided in sections: 500 feet, 1,000 feet, 1,500 feet, and 2,000 feet. And the same goes for the downside: minus 500, minus 1,000, minus 1,500, minus 2,000 feet. This concludes the primary 6 instruments, And now let us continue exploring the rest of this cockpit. The magnetic compass, this is standard with all aircraft and used for magnetic direction and to align the directional indicator to the correct magnetic heading. This aircraft is fitted with an electronic temperature and endurance indicator. It will indicate your outside temperature in degrees Celsius or Fahrenheit depending on your computer system settings. And it will also indicate your current endurance of the current fuel load of your aircraft. We will look at a fuel gauge. This is an indication in gallons of the quantity of fuel carried in your left and in your right tank, and it can also give you a good indication whether there's an imbalance in fuel flow in your aircraft. The EGT and fuel flow gauges. EGT is your exhaust gas temperature gauge and indicates the temperature at which combustion is burning. This temperature is directly proportional to the aircraft's mixture control and can adversely affect performance as well as mechanical endurance. The leaner the mixture, the higher the EGT temperature. Consult your aircraft pilot operating handbook for the optimal temperature setting and adjust the mixture accordingly to the aircraft that you are flying. The fuel flow gauge indicates the current rate of fuel is flowing to the combustion chamber. That is measured by gallons per hour. Then we'll have the oil gauge, which will indicate your oil temperature. The green is obviously optimal range, as well as your oil pressure. This gauge will indicate the vacuum of the aircraft in inches mercury. The green bar indicates the optimal operational vacuum of this aircraft, which obviously have influence on your artificial horizon as well as your directional indicator or any other instruments that is gyro driven, which works off the vacuum pump. You'll also have a battery's amperage indicator. In this specific case, if the battery indicator is on the positive or on the upside, that means it's positive charge in the battery. If it's on the negative side, that means your battery is discharging, and this could indicate a failure on your generator or your aircraft alternator. Now let's look at the lower panels in this aircraft. Here you can see all your aircraft fuses, and they are marked for what they are functional to. COM radio 1 not working, you might find that this fuse might be popped. You'll also have your aircraft starter indication. You'll have your master switch operating your battery as well as your alternator, and they both normally is switched onto the on mode when you start this aircraft. Other flip switches here are your fuel pumps, your beacons, landing lights, taxi lights, navigation lights, and so forth, and even your pilot heat. Your main avionics switch, you can switch different buses which will drive different instruments and indications inside your aircraft. You can consult your pilot operating handbook, or by default we just switch them both on. Below the pilot feet you will find a handbrake, and you will find your rudder pedals for left and right rudder movement, as well as for toe brakes. Moving across to the center lower panel, there you will find your fuel selector. You can either decide left, both tanks on, or just the right tank. Above that you will find your fuel cutoff switch. When you shut down your aircraft, we normally pull the fuel cutoff switch. Some aircraft selectors might have a fuel off, and then a left, and then a right, and then both. In this aircraft we only have a fuel cutoff switch. To the right, lower center of your panels, you will have your trim wheel. This little trim wheel operates a little edge tab on your right elevator of the aircraft, and adjusting the trim wheel up and down will move this trim tab like a little flap up or down, and this will regulate the pitch of the aircraft, which obviously is important to assist the pilot in descending, ascending or climbing, as well as landing. Moving up, you will have your different light switches. That's just to set the ambient lights on this panel, as well as the radios and also in terms of the pedestal. To the right you will have a little switch called the alt static air switch. Now the alt static air switch is important if you suspect that your pitot switch, which operates your altimeter, your vertical speed indicator as well as your airspeed indicator, is for some reason malfunctioning or is blocked. By switching this switch on, static air will be pulled from the cockpit cabin, feeding these instruments, assisting you in reading the correct altitude as well as your airspeed and your vertical descent speed, which is indicated by the vertical speed indicator. Over here we will have our throttle control. That's your power on and power off, as well as your mixture control, full reach and full lean. Over here we will have the RPM indicator. That's the revolutions per minute of your aircraft motor turning, as well as a tachometer which will indicate the amount of hours. To the right you will have your ADF needle. This needle operates on NDB frequencies, and it'll indicate your aircraft's relative position to an NDB once it's tuned onto your ADF radio. Above that we will have the Omni bearing selector for nav2. This is tuned to a VOR, and you will have an indication whether the frequency that you tune to are valid. If you have what we call a red flag, that means that frequency is not valid, or it'll indicate to and from. The vertical needle will tell you whether you are left or you are right of this, or the VOR is either left or right of you. That'll be your position over there. Above that we will have the Omni bearing selector for nav radio 1. It's got the similar same functions as the OBS for nav2, except that you will be able to do glide slope approaches. And you'll have a vertical needle indicating you are left or right of the glide slope, as well as whether you are above or below the glide slope, if this is tuned to the correct ILS frequency. Then we have the navigational switch indicator. That's most probably your mode, whether your aircraft is flying on nav, which is obviously radios are tuned to VORs, or whether it's flying onto the GPS in the specific aircraft. On the center stack we will have our radio stack. In this case this aircraft does not have a separate radio stack, and it will use the Garmin 530 as a radio stack to select your COM1 and your NAV1 frequencies. Many other aircraft, or if you fly with SciTech panels, you'll have the option to adjust your radio stacks for NAV2 and for COM2. There you can switch between your active and standby for COM1, active and standby for NAV1. Make sure when you communicate through COM1 that your COM1 switch is enabled, and if you want to monitor COM2, that COM2 is enabled. If both are enabled, primary communication will be through your communication 1 radio, and you'll only be able to monitor COM2 radio. If it's set to COM2, then all primary communication will run through COM2. This aircraft is further fitted with a backup Garmin 430, which has similar functions as the Garmin 530. Then we'll come to your transponder stack. You can set the frequency of your transponder to whatever you would like to. Let's just zero out quickly, and we'll set it to 2000. Your transponder currently in the mode selector is off. You can put it onto standby, put it onto alt, or you can squawk alt itself, or even ident. Below that you will have your autopilot panel. Autopilot is enabled. and whether you're flying heading or whether you're flying nav on your nav frequency 1, whether you are doing a approach or you want to do a reverse approach onto your nav 1 radio. Maintain altitude or a certain vertical speed for the climb out and the descent. To the right you have your ADF selector, which obviously is for your NDB frequency selection. And moving down you will have your flap selector, so you can set your flaps second, first notch of flaps, or you can go full flaps. These selectors are to pull them for cabin heat, and if they are functional, or you can have certain cabin air features via those switches. To the right, this aircraft is equipped with the ELT, that's an emergency transponder. It is normally set to auto, so it will detect any unforeseen crash landings or very hard landings, almost like a glass detector for broken glass, and it will activate itself, or you can activate it manually if this is functional. And lastly, you will have your hops meter. Hops meters are normally used for rental of aircraft and is not really used within our simulators. Captains, this will conclude the cockpit layout of the Cessna 172. Stay tuned and subscribe to our channel, and click the bell to be notified of any updates. Safe landings.